Hello there, Mr. Sutton here, bringing you this lesson on mean, median, and mode. In this lesson, we'll be finding these what we call measures of central tendency in a variety of data structures, including lists, dot plots, stem and leaf plots, and frequency tables.
For the warm-up on this one, let's say that a car dealership has clients fill out a customer satisfaction survey when they pick up their cars. Final question is, on a scale of 1 to 10, how happy were you with our service? And the results are given below. So we've got a 4, a 3, a 4, 6. Ooh, that customer's really unhappy, too. So based on these numbers, the manager asks you overall, how satisfied are customers? What single number should you say? Pause the video and contemplate this. All right, so we're going to talk about a few different ways of representing what we call the central tendency of data. We can summarize data using one of three different summarizing numbers: the mean, the median, and the mode. The first of these, the mean, is when you add up the data and divide by how many items there are. So sum of the data items divided by number of data items. That gives us the mean, also called the average. The next number we're going to talk about is the median. This is where you take the middle value after putting the numbers in order. And this is fairly easy to pick out if you have an odd number of numbers. It's just whatever the middle number is. However, what if you have an even number, where you have two middle numbers when all is said and done? In that case, if there's two middle numbers, we just find their mean. Either way, the idea here is that half the data is lower than the median and half the data is higher. The last number we'll talk about is the mode. This is just the number that appears the most. And this is probably the most useful when you're talking about data sets that don't just have numbers, like if you want to know the most popular ice cream flavor or something like that. It's kind of hard to average ice cream flavors together, but the mode works a little better in a case like that. Now, this one's also easy to pick out if you have numbers arranged in order. And there's a couple oddball cases, like if you have a tie, then you can have more than one mode. Now, this also has an exception. If all the numbers appear exactly once, that doesn't count as having every number be the mode. Then we just say that there is no mode. There's no number that appears the most. Now that we've gone over different ways of summarizing data, let's use those on this data set. So first, finding the mean. Again, we're adding all the numbers together and dividing it by the number of numbers. So we've got 4 plus 3 plus 4 and so on and so forth, all divided by, well, how many are there? 8. So this is what the mean is going to look like. We'll just plug that into the calculator now. So when you're plugging all this in, since you have all this happening on top of a fraction here, you're going to want to put a parentheses around all those things being added together before you go ahead and divide by 8. And that comes out to about, we'll say 3.88 if we round it off to 2 decimals. All right, let's take a look at the rest of these now. So there's our mean. The median, we're going to have to put these numbers in order. So let's start sorting these. The smallest number is 2, and then we've got a 3, we've got another 3, and if you want, you can cross these numbers off as you go, just so you don't double count anything. And then let's see, we have 1, 2, 3 4s kicking around in there, and then we've got a 5 and a 6. All right, so that's all of them. Now, to find the middle numbers, I mean, there's not a whole lot of numbers here. It's pretty easy to see what the middles are. But if you had a larger set of data, a good strategy is to cross off one number at each end until you only have 1 or 2 numbers left in the middle. So, for example, the 2 and the 6 will cross off, and then the 3 and the 5, and then the 3 and the 4, and that leaves us with 2 middle numbers. Now, I said that when you have 2 middle numbers to find the median, you have to average the numbers together. So 4 plus 4 over 2, clearly 4 is between 4 and 4, so we end up with 4 for a median. And then the next one now, we've got the mode. That's the one that appears the most. That's just going to be 4 because there's 3 4s and there's not 3 or more of any other number out there. So there we have it, mean, median, and mode. So here's another set of data. Pause the video and see if you can find the mean, median, and mode of this data set on your own. All right, let's see how that went. So for finding the mean, again, we're going to add all of this together and divide by the number of numbers. Let's go ahead and do that on the calculator. So I entered all of those in the calculator carefully off screen, and I ended up with 777. Now, counting up the number of these, we've got, let's see, 4, 8, 12, and 16 of them all together. So we need 777 divided by 16. So we'll go back to the calculator, Divide this by 16, and that gives us about 48.56 for the mean. Now for the median, again, we have to put these in order. So let's see, what's the smallest number out here? We got 43. Is there anything smaller than, 42? That's even smaller. And there's nothing in the 30s, so we've got a 42. And then 43 would be the next number. We've got 1, 2, no, that's not a 43. Here's a 43. Here's another 43, so 3 of those. And then after that, any 44s? Nope. Let's see here. 47. That's the next biggest one. We got 1, 2, 3, 4 of those 47s. No 48s, but we've got a 49. And that's the only 49. Let's see, what else is there? A 50. We've got 2 50s. We've got a 52. Any other 52s? Nope. And then we've got, let's see, 53 here. There's no other 53s, are there? Nope. And then 54. We've got a 54 here and a 54 here, so 2 54s. Anything else? Oh, we've got a 56. So, there we go. We've got them all together now. Let's start crossing things off. So 42 and 56, 43, 54, 43, the other 54. We've got 43 and a 53. And we've got, let's see, 47, 47, 47, 52, 50, 50, and 47 and 49 are the only ones left standing in the middle. Averaging those together, we end up with 48 for the median. Now for the mode, again, if you've got these already sorted, this is pretty quick. We've got, let's see, 3 43s. Can we do better? We have 4 47s. And there's no number that appears more than that, so 47 is our mode. Now that we've gotten some practice with mean, median, and mode, we're going to change how we represent our data. So far we've just been dealing with lists of numbers. Now we're going to turn our attention to something called the stem and leaf plot. The way this works is we're basically just condensing data using a stem and a leaf. The stem is just the first digits of your numbers, and the leaves are the last digits. So for example, this 8 is the stem and 4 is the leaf. This gives us the number 84. Then we have 85, 85, and so on. So it just saves a little bit of space when you have the same first digits repeated over and over again. So how do we find mean, median, and mode with this? Well, for mean, we're going to write out the numbers first and then count up the leaves. So we've got 84, 85, and pause the video and write out the rest of them. All right, so now we've got another 85. This is 92, and we've got 2 more of those. 94, 97, and finally 100. And how many leaves do we have? Because that's the number of items that we have. Let's see, we've got 3 up here. This is another 5 plus another 1, so that's a grand total of 9. Let's go ahead and add that up now. And if you do that on the calculator, you're going to end up having 821 altogether divided by 9, which comes out to about 91.2. Okay, let's keep going now. We're going to do the median. Now, the median, remember, your numbers have to be in order. The nice thing about the stem and the leaf plot is that this is in order already. Since our leaves are already in order, we can just use our cross-off method on them in the order that they're given. So, for example, 4 and 0, that's really 84 and 100. We can cross those off and see if you can cross off the rest of these and figure out the middle number. All right, so we had a 5 and a 7, and then we've got this 5 and this 4. And then finally, we've got 2 and 2, leaving us with a middle number of 2. That 2 really means that 92 is our median, so careful writing that out as an actual number. And then finally, with the mode, we just find the leaf that's repeated the most and write that number. So we see that 2 is repeated 3 times. Nothing else gets that high on repetition. So then 92 is also going to be our mode. This next one is a dot plot, in which each number is represented by a dot on this number line. So for example, these 2 dots here represent 47 and 47. Based off of this, see if you can figure out a quick way of figuring out the mean, median, and mode from this data set. All right, so for finding our mean, we're just going to write out our numbers, kind of like we did with the stem and leaf plot. And a nice little shortcut you can use on this is multiplication for repeated dots. And then we'll count up the dots. So here we've got 47, and we've got 2 of those. Here we've got 3 48s, and then we have 2 of these 49s, and we have a 54. And then counting up the dots, let's see, this is going to be 2, 5, 7, 8 dots altogether. So if you do this on the calculator, let's do this now. Entering all those in the calculator, that's a grand total of 390, and divided by 8, that's going to give us 48.75. Next, let's find the median. So same kind of idea as the stem and leaf. We're just going to, since these dots are in order, we're just going to use our cross-off method. So we've got this dot in this dot, and then let's see, this dot and one of these. It doesn't really matter if you go from top to bottom or bottom to top because they're all the same number. And then we've got one of these and one of these. That leaves us with 2 of these dots here. And that is going to be, let's see, 48. So we have the average of 48 and 48, which is, of course, 48. And then finally, we have the mode, which is just whoever has the most dots. This is what these dot plots are really nice for, is figuring out the mode. So that's clearly going to be this 48 that has 3 dots higher than anything else. This next data type we'll look at is called a frequency table. As the title suggests, this is a table that tells you how many of each number we have. In this one, which I think is supposed to represent bowling balls, for example, we have 3 of these 11-pound bowling balls, 10 12-pounders, 2 13-pounders, and so on and so forth. So we need to figure out mean, median, and mode given something that looks like this. Now we have to be very careful here. A lot of people who aren't used to these are just going to go ahead and, for mean, for example, they're going to try to add these 5 numbers together, divide it by 5, and of course they get 13. But that is not the way to do it because there are not the same number of 11-pounders as there are 12-pounders and all the rest of these. So we need to find the total combined weight of all these balls by multiplying each number, each poundage here, by the frequency of that number. So for example, we need 3 times 11, we need 10 times 12, 2 times 13, 18 times 14, and 17 times 15, and we need to add all of those products together. Now that's not enough because we also need to divide by the total number of balls. So for that we need to basically add up all of these frequencies down here because this tells us the number of each kind of ball, so we need to add all those together. So let's go ahead and do both of those separately on the calculator. And I could just plug this all in the calculator, but I actually want to know exactly how many items I have for the next couple problems. So let's do that now. So here's my numerator where I'm adding up all of those frequencies, and that's all going to come out to about 686. And now let me do my denominator. Adding all those together, we've got 50. So we've got 686 divided by 50. Now we just have to divide numbers 1 by 2 here. So that's going to come out to a grand total of 13.72. That is the average or mean weight of the bowling ball here. For the next part of this problem, we're going to find the median, and I've got a clean slide here because there's more to talk about for this. Now again, when you're finding median, if you haven't seen one of these types of tables before, it's too easy to fall into the trap of just taking this middle number of 13 because these numbers are in order and it looks like it's a sorted list. But again, if you actually write all these out, we've got 11, 11, 11, 12, 12, 12, and so on and so forth. So you have to take into account again how many of each of these number there are. So for median, what I'm going to do, I want to figure out the index number of the middle number, right? So if I've got 50 balls here, then which one gives me the median if I were to write all of these out in order? To figure something like this out, I'm going to add 1 to the number of items, and then I'm going to divide that by 2. That'll actually give me the index number of the middle item. So for example, here we've got 50 bowling balls, add 1 to that, and divide by 2, and that gives me the index number of the middle bowling ball, which is bowling ball number 25 and a half. Now, the reason this looks kind of weird with this 1/2, we have an even number of bowling balls here, so there isn't actually a middle number. So we want whatever the bowling ball would be between bowling balls 25 and 26. So let's go ahead now and figure out what range that falls in. To do this, we're going to start adding these frequencies together until we go past this middle index number. So for example, we've got 3 bowling balls here, that's the 11-pounders. If we throw in the 12 bowling balls, that brings us to 13 altogether. 2 more of these 13-pounders gives us 15. And then if we throw in the 18 14-pounders, we've already listed out essentially 33 numbers. Now, we were looking for number 25 and a half. That falls between the 15th and 33rd bowling ball. So that means that our 25 and a half bowling ball is a 14-pounder. So that represents our median. And the last one, mode, this is the easiest one of all. This is just the item with the highest frequency. This is kind of what these tables were born to do. And looking here, the highest number in the number of balls category, that's this 18, that corresponds again to the 14-pounders. So 14 pounds is our mode. So that's it for mean, median, and mode. Until next time, this is Mr. Sutton signing off.